Welcome to Chibuzor Mathphysics. In today's video, we are going to continue our eigenvalues and eigenvectors series. And we've already covered question 1 up to question 2. In today's video, we want to continue with question number 3. And question 3 says that given that matrix A is given as a 2 by 2 matrix, that is 1 0 0 1. And matrix B, which is also 2 by 2 matrix, 1 2 0 1. So you are required to find the eigenvalues of A and B. The second, we are going to find the eigenvalues for AB and BA. And at the end, we are to determine if the eigenvalues of AB is equal to the eigenvalues of BA. So you can pause the video at any point and try doing it yourself. You can as well pause the video if you know how to figure it out. Otherwise, follow systematically and you will see how to get to this. I remain your friend Galagash, and if you are joining us, click on the subscribe button so that you'll be notified as we upload subsequent videos. Stay tuned and enjoy the computations. Here the question 3. So we are expected to find A and B, given that a matrix A is 1 0 1 1, matrix B is 1 2, and then we have 0 0 1. We are to find the eigenvalues of A and B. And option B, we are to find the eigenvalues of AB and then BA, and at the end we are to determine if the eigenvalues of AB is equal to the eigenvalues of BA. So let us see how to do that. So we know that in dealing with matrices, especially when we're talking about the eigenvalues, we need to find it is a lambda I, which is our equation. You can watch the previous video so that you know how we get this formula. Of course, this is the equation that we can use to determine the eigenvalues, and this must be equal to 0. We are trying to solve for A. This A, we are solving for A. This is matrix A. So that we will have, this will be implied that we will have, if we multiply this by the identity matrix, it is simply 1 minus lambda. We have 0, then we have 1, then we have 1 minus lambda. So that now we can find the determinant and solve this as systems of equation. Of course, this must be equal to 0 because we are looking for the determinant. So therefore, when you have this type of identity, 1 minus lambda and 1 minus lambda, what is telling us is that we have 1 minus lambda. We also have 1 minus lambda. Of course, if you multiply this 1 minus by 0, you simply get 0. So this will implies that our lambda 1 will be equals to lambda 2, and this is equals to 1 because our lambda in this case is simply 1, because lambda 1 is simply lambda 2, and this will be the first answer to this question A. We are to find the eigenvalues for A. So the eigenvalues for A is 1 because lambda 1 is equals to lambda 2. So let us now find the eigenvalues for B. B minus lambda I equals to 0. Now we need to solve for this equation using this matrix. So this will implies that we'll have this implies that we have 1 minus lambda, then we have 2, then we have 0, and then we have 1 minus lambda. Of course, this must be equal to 0 when we solve for the determinant for this. So again, you observe we are having the same identity, 1 and 1. 2 by 0 will simply be 0. So it means that 1 minus lambda, this implies that 1 minus lambda and 1 minus lambda is the only thing left, and this must be equal to 0. Implies that our lambda 1 is simply equals to lambda 2, just like we have in the beginning. This is also equals to 1. So 1 is the eigenvalues for matrix B. Now we need to solve for matrix AB and matrix BA. To do that, we first of all need to multiply. AB simply means multiplication, and BA is also multiplication. Let us see how to handle this question, which is the second question in this video. Stay tuned and enjoy. So AB, which is this is question B, you have to find AB. So AB in this case will be equals to, we have the matrix 1 0, then we have 1 1, 1 0, and then we have 1 1, and we are multiplying with B, and B is 1 2 0 1, 1 2 0 1. Usually you have to multiply the columns with the rows of these two equations, and for easier you can use your calculator and try to multiply this matrix, and that will make your work easier. So let's use the calculator to multiply the two matrices. First of all, you go to your mode. Matrix is number 6. Let's take matrix 1. Matrix 1, and it is 2 by 2. Let's take 5 as 2 by 2, 5. And matrix A here we have 1. It is equals to 0. This is equals to 0, 1. This is equals to 1, which is equals to 1. Confirm the values, 1 0 1 1. That's what we have in matrix A. Go back to matrix. Let's go back to matrix. Just a minute. Matrix is number 6. Now matrix B is 2. It is also 2 by 2. Take 5. And let's see what we have. In matrix B, it is 2. We have 2, 1. We have 1, which is 1 here. We have 2. We have 2. Then we have 0. And then we have 1. So now this is what we have, 1 2 0 1. So now let us multiply the two matrices. Go back to shift, take option 4, matrix A. Matrix A is 3. Multiply this by, go back, shift 4, matrix B is 4. So matrix A multiplied by matrix B will give you a new matrix. So it is 1 2 1 3, 1 2 1 3, 1 2 1 3. So let's have that down. When we multiply these two matrices, we will simply get 1 2 1 3. So this is our new matrix. Now that we have our new matrix, this implies that we need to find AB. This is matrix AB minus lambda I. And this must be equal to 0. Implies that we need now to multiply this by the identity matrix. This is 1 minus lambda. Then we have 2. We have 1. Then we have 3 minus lambda. The minus lambda, of course, this must be equal to 0. So now that we have this, we can solve. This will tell you that you have, this will simply be 1 minus lambda, and you will still have 3 minus lambda. We have 3 minus lambda, 3 minus lambda, and this must be equal to 0. Of course, we have 2 here, so this is minus 2. You can have that down here. You can have that down. 3 minus lambda, then we have minus 2 is equal to 0. Solving for this, you will notice that if you open up this, you will simply have this will give you 3 minus lambda, 3 minus lambda minus 3 lambda plus lambda squared minus 2 is equals to 0, because we say 1 by 3 will give you 3, negative lambda by 3 will give us negative lambda, then we have lambda squared, so that we'll end up with lambda squared minus 4 lambda plus 1, because 3 minus 2 will give us 1, and this must be equal to 0. Solving this as a system of equation, our lambda 1 will simply be given by 2 plus root 3, and our lambda 2 will be given by 2 minus root 3. You can plug this in your calculator using the equation mode to solve this. If you do that, you will simply get this as our lambda 1 and lambda 2. So now let us proceed to see what will be the value for BA. What will be the value for BA? Observe that here what we did, we simply open up this, and we know that 1 times 3 is how we get 3. 1 times lambda, we simply get negative lambda. Negative lambda times 3, you get negative 3 lambda, and then we have lambda squared, lambda times lambda, and minus 2, and that gives us equal to 0. If we reduce that equation, we simply have lambda squared minus 4 lambda plus 1 is equal to 0, which means that lambda 1 is 2 plus root 3, and the lambda 2 is simply 2 minus root 3. So now let us find the eigenvalues of BA. This is AB, so let's find the eigenvalues for BA. So for BA, this will simply be equals to our B is here. It is 1, 2, 1, 2, 0, 1, 1, 2, 0, 1, and our A is 1, 0, 1, 1, 1, 0, 1, 1. You know how we multiplied these two matrices, rows by columns, or you can use your calculator to do that. And if you do that, the matrix multiplication here, we will simply get a new matrix, which is 3, 2, 1, 1, 3, 2, 1, 1. This will be the matrix, the new matrix that we got. So now we can solve for BA, because this is BA, we are solving for BA. So BA minus lambda I will be equal to 0. This means that we have a matrix. When we multiply, it will be 3 minus lambda, 3 minus lambda, 2, 1, then 1 minus lambda. And this also must be equal to 0. So solving, we will simply have 3 minus lambda, 3 minus lambda, then we have 1 minus lambda, 1 minus lambda, and then we have minus 2. 2 times 1 minus 2, and this will be equal to 0. If you observe, it looks like the same in the first one, so this can mean that we have 3 minus 4 lambda plus lambda squared minus 2 will be equal to 0. And of course, we can use the quadratic formula to solve these. And we can as well use our calculator, and if we do that, lambda 1 will simply be given by 2 plus root 3, and lambda 2 will be given by 2 minus root 3. If you observe, you will notice that this is the same values. This is the same values that we got in in BA.